Types of redox reaction. There are four types. One is combination reaction, second one is decomposition reaction, third one is displacement reaction, and fourth one is disproportionation reaction. First we will see what is the combination reaction. Already you are learned in the lower class level, that is in class 10. The combination reaction may be usually denoted in this manner, that is A plus B gives C. That means two different reactant gives a single product, that is called combination reaction. Here either A and B or both A and B must be in the elemental form for such a reaction to be a redox reaction. So all combustion reaction which make use of elemental dioxygen as well as other reaction involving elements other than dioxygen are redox reaction. See, this is the example. Here the carbon react with oxygen to form carbon dioxide. Here this zero, this plus 4, this minus 2 indicates oxidation state of their elements and their compound. Here the carbon is free state, so that 0. Here oxygen also free state, so that 0 oxidation number. Then here the carbon is oxidized and oxygen is reduced, so that they have different charges. And similarly, magnesium react with nitrogen, that is the other than oxygen, dioxygen. In this reaction example is other than dioxygen. See, here the magnesium nitride is formed. Here the elemental state, that is the free state, and here also nitrogen is a free state. It converts to plus 2 oxidation state and minus 3 oxidation for nitrogen. Then methane gas react with oxygen gas to form carbon dioxide gas and water. So here minus 4 carbon having minus 4, hydrogen plus 1, oxygen 0 state, here plus 4 and minus 2, like this is the oxidation state. So these are the examples of the combination reaction. Decomposition reaction is just opposite of the combination reaction. The opposite of the combination reaction means here the one reactant undergoes a decomposition reaction to gives 2 or more products. So here this is called a decomposition reaction. That's mean here the water molecules on heating to break down into two molecules, that is hydrogen gas and the oxygen gas. Here oxidation state of hydrogen is plus 1 and oxygen is minus 2. Here it breaks down to elemental form, that is why they are free state. So 0 oxidation state of the both elements. Then look at this next example is sodium hydride. Here one reactant undergoes a decomposition, that is on heating. So there is a thermal reaction. It gives its breakdowns to elemental form, that is sodium and hydrogen. Here having plus 1 and minus 1 the oxidation number, and here 0 for nitrogen, sodium, and hydrogen for 0. Then look at this reaction. The potassium chloride on heating, potassium chloride and oxygen gas is given here. Already we seen in in combination reaction, that is methane react with oxygen to form carbon dioxide and water molecule. In that reaction, the hydrogen never change the oxidation number. That is, the hydrogen in reactant side also plus 1 and the product side is also plus 1. But in this, similarly, look at this, in this reaction, the potassium, look at here, plus 1 oxidation here in this reactant side, and look at in the right hand side, that is in product side, plus 1. Here, the potassium chlorate and potassium chloride, there is no oxidation change and there is no oxidation number change in the potassium element. So here it may be also noted here that all decomposition reaction are not redox reaction. For example, this is decomposition of the calcium carbonate is not a redox reaction. because there is no change in the oxidation number. Look at here, the calcium carbonate on heating to gives calcium oxide and the carbon dioxide. So here the calcium having +2 oxidation state, carbon having +4 oxidation state, and oxygen having -2 oxidation state. Look at here, the calcium here also the +2, and oxygen -2, here also -2, and the carbon +2 and -2. So here the oxidation status never change. In calcium, here also calcium is +2. So that this is not a redox reaction. This type of reaction also called not a redox reaction. That is also called decomposition reaction, but not a redox reaction. Next is a displacement reaction. Displacement reaction having two types, that is metal displacement reaction, another one is the non-metal displacement reaction. See, generally the displacement reaction means there is the ion, that is ion or atom in a compound is replaced by ion or atom, that is the another element. So usually we can write in previous class, in lower class we studied that is x plus y z gives x z plus y. That is the displacement reaction fit into two categories, that is one is metal displacement reaction, another one is non-metal displacement reaction. First, metal displacement reaction, in a metal compound can be displaced by another metal in the uncombined state. See, the metal displacement reaction find many application in metallurgical process in which pure metals are obtained from their compounds in ore. See, look at these are the examples of metal displacement reaction. So copper sulfate react with zinc to produce copper and the zinc sulfate. Vanadium pentoxide react with calcium to form, that is on heating, to give vanadium and the calcium oxide. Here copper is reducers, zinc is oxidizers, because copper having +2 oxidation state, here the right hand side copper having 0 oxidation state, here zinc having 0 oxidation state, in the right hand side zinc is +2 oxidation state. So this is also redox reaction. In vanadium pentoxide, vanadium here +5 oxidation state and calcium having 0 oxidation state. Look at here, vanadium having 0, that's mean reducer, and calcium is oxidizers. So +2 oxidation state. Next is titanium chloride. There is titanium tetrachloride having titanium having +4 oxidation state and it reduces to titanium. Then magnesium oxidizes to Mg2+, Mg having 0 oxidation state and +2 oxidation state in the right hand side, that is on heating. Then the chromium oxide, that chromium oxide, here the chromium having +3 oxidation state, in the right hand side having 0 oxidation state, that's mean reduces. In aluminum oxidizes aluminum to Al3+ state, so +3 oxidation state here. So chromium oxide gives react with the aluminum to on heating, aluminum oxide and chromium is obtained. So this is the metal displacement reaction examples. Then here that in each case that is the reducing metal in better reducing agent than the one that is the being reduced, which is evidently so more capable to lose electron as compared to the one is reduced. Okay. Then the non-metal displacement reaction. So the non-metal displacement redox reaction include hydrogen displacement and a rarely occurring reaction involving oxygen displacement reaction. Here all alkali metals and some alkaline earth metals are very good reductants, will displace hydrogen from cold water. See, the sodium react with the cold water to form what happened, the sodium hydroxide and the hydrogen gas is produced. Here the sodium having 0 state, sodium in this right hand side +1 oxidation state, hydrogen having +1 oxidation, so reduced to hydrogen. Okay. Then the calcium 0 state, hydrogen is +1 state. Here the calcium is oxidizers and hydrogenous reduces. Then the magnesium, that is the less active metals such as magnesium and the iron with steam to produce dihydrogen gas. So with steam to produce dihydrogen gas. Here magnesium having 0 oxidation state and magnesium having in the right hand side +2 oxidation state. So magnesium is oxidizes and hydrogen is reduces from water. Okay. Then iron also, iron 0 oxidation state, hydrogen having +1 oxidation state and undergoes steaming to produce hydrogen gas and the iron 3 oxide. So that iron 3 oxidation state here 0. So that iron is oxidized to iron 3 state, hydrogen is reduced to hydrogen, that is from water. Okay. So this is the non-metal displacement reaction. See, many metals, including those which do not react with cold water, are capable of displacing hydrogen from acid. See, dihydrogen from acid may even be produced by such metals which do not react with the steam. That is cadmium and tin are the examples of such metals. So, if you here the examples of the displacement of hydrogen from acids are, that is zinc reactive with hydrogen chloride aqueous solution, that is dilute HCl to produce zinc chloride and hydrogen gas. So here zinc is oxidizes and hydrogen is reduces. Then magnesium reactive with hydrogen chloride aqueous solution of hydrogen chloride to form magnesium chloride and hydrogen. Here magnesium is oxidizes and hydrogen is reduces because of 0 +1 to 0. Then iron reacted with HCl to produce iron chloride and H2 gas, that is hydrogen gas. Here iron is oxidizes and hydrogen is reduces. Okay. So here the reaction that the two reactions, the first two reactions are used to prepare the dihydrogen gas in the laboratory, the first two reactions. Here the reactivity of metal is reflected in the rate of hydrogen gas evaluation, which is the slowest for the least active metal iron. Okay, and the fastest for the most reactive metal is magnesium. So very less active metals which may occur in the native state such as silver and gold do not react even with the hydrogen chloride, that is hydrochloric acid. So already we learned that is the metals zinc, copper and silver, though tendency to lose electrons shows their reducing activity in this order, that is zinc is greater than, copper is greater than silver. So like metals activity series also exist for the halogen. So the power of these elements as oxidizing agent decreases as we move down the group, that is from fluorine to iodine, the group 17 elements. So this implies that fluorine is so reactive that it can replace the chloride, bromide and iodide ions in the solution. So in fact the fluorine is so reactive that it attacks water and displaces the oxygen of water. See, look at this reaction. Here displaces of fluorine, that is reactive with water and fluorine, that is to form hydrogen fluoride and oxygen. Here the fluorine is 0 oxidation state, that's fluorine is reduces here. Okay. Then it is for this reaction, the reason that the displacement reaction of chlorine, bromine and iodine using fluorine are not generally carried out in the aqueous solution. That on the other hand, that is chlorine can displace bromide and iodide ions in the aqueous solution. Look at this reaction, chlorine and iodine. See, the chlorine react with the potassium bromide to form potassium chloride and bromine, liquid bromine. Similarly, chlorine gas react with potassium iodide to form potassium chloride and iodine gas. Okay, here the bromine and iodine are colored and dissolved in carbon tetrachloride, can easily be identified from the color of the solution. So this reaction we can write in the ionic form, that is ionic form of the reaction, this 2 reaction is Cl2 is Br minus. We can write, no need to write KBr, just we can write it Br minus, and 2Cl minus gives Br2. Then the second reaction, the ionic form is Cl2 react with, that is 2 iodide ion gives 2Cl minus ion and iodine. Okay. So this two reaction, this is the reaction, this and this form the basis of their identifying of bromide ion and the iodide ion in the laboratory, though the test is popularly known as the layer test. Okay, this is called a layer test. It may be not be out of the place of the mention here. The bromine likewise can displace the iodine ion in the solution. See, bromine iodide ion use bromide ion and the iodine. Then the halogen displacement reaction have a direct industrial application, so that the recovery of halogen from their halides require the oxidation process. Usually we can represent like this, that is 2x gives x2 plus 2 electron. Here the x notes the halogen element, whereas the chemical means are available to oxidize chloride ion, bromide ion and the iodide ion. As fluorine is the strongest oxidizing agent, there is no way to convert fluoride ion. There is no convert to fluoride ion to fluorine. Because the only way to achieve the fluorine to fluoride ion, that is fluorine to fluoride ion, that is 2F minus. Fluoride ion oxidizes electrolytically. That you can learn in next section, that is that standard electrode potential value. The standard electrode potential, that is the E0 value, is nearly 2.87 volt. That is why the fluorine is the strongest oxidizing agent. You can see the table number 8.1. That is why the reason, that is fluorine to fluoride ion is possible, fluoride ions to fluorine is not possible. Next is the disproportionation reaction. This is a special type of the redox reaction. Usually the disproportionation reaction, the element one oxidation status simultaneously oxidizes and reduces. That means the same species undergoes oxidation as well as the reduction. See, one of the reacting substance in a disproportionate reaction always contains an element that can exist in at least 3 oxidation states. So the element in the form of reacting substance is in the intermediate oxidation state, and both higher and lower oxidation state of that element are formed in the reaction. So the decomposition of hydrogen peroxide, see, look at this, the hydrogen peroxide is a familiar example of this reaction. Here the oxygen experiences a disproportionation reaction. See, look at this reaction. Here the oxygen of peroxide, which is present in -1, okay, -1 oxidation state, it converts to 0 oxidation state in O2, that is in O2, and decreases -2 oxidation state in H2O. Look at here, -2 oxidation state. So look at this reaction. This is phosphorus, sulfur and chlorine. This 3 reaction undergoes disproportionation reaction in the alkaline medium. See, the phosphorus having -3 charge and here the +1 charge. Okay, then sulfur here -2 and the +2 here. Okay, so the same species undergoes oxidation as well as the reduction. In the same case, the chlorine also, here the 0 state and here +1 and here one is -1. So the same species undergoes oxidation as well as the reduction is called disproportionation reaction. This is also redox reaction only. Okay, so this reaction describes the formation of the household bleaching agent, like the hypochlorite ion, that is this is called hypochlorite ion formed in the reaction oxidize the color bearing strains of the substances to colorless compounds. So it is interest to mention here that whereas the bromine and the iodine follow the same trend as the exhibition by chlorine in the reaction, that is we seen that previous reaction, that fluorine shows the deviation from this behavior when it react with alkali. So the reaction that takes place in the case of fluorine fluorinous. So this is the reaction. Fluorine react with base to form fluoride ion and oxygen difluoride. Okay. The fluorine is not surprising for us. Then we know that the limitation of fluorine, that being a most electronegative element, it cannot exhibit any positive oxidation state. I said only exception is hypofluorous acid. So this means that among halogen, fluorine does not show disproportionation tendency. Okay.